Okay, guys, so we're going to look at the last we were looking at thermosetting plastics, thermoplastics, and elastomers, and we were looking at the the characteristics of each. This week we'll look at how they are made. So essentially, polymerization is how these plastics are made. Each of them is made differently. The last day I showed you this diagram here, so that we have these chain link molecules all on top of each other. Each of those chain link molecules are made up of loads of different molecules in a line, essentially to make a chain. That's where the name chain link molecules comes from. Okay, so what we're going to look at is how these chains are made. The first one we're going to look at is a thing known as addition polymerization. You can see there addition, and essentially with addition, all you have to do is just add each molecule onto each other. Down here, guys, this one is known as the polyethylene, or this one on its own is ethylene. Okay, because hasn't been made into a chain link molecule yet. That's the molecule on its own, the ethylene molecule. Okay, what happens, guys, is just let me point out a few things. Your H are hydrogen, C is carbon. In the exam, you do not need to remember these H's and C's. You could replace the C's with B's and the H with A's, as long as you show that all four around the outside are the same, the two in the middle are the same. That's perfect. This thing here in the middle, this equals, it looks like, that's known as a double bond. Okay, so it's a double bond. Okay, and a double bond is very, very hard to break. So there is a way of breaking it, and I'll talk you through it in a sec. So you have a double bond in the middle. So how you break this double bond is we use a thing known as you probably would have heard this from science. It's a thing known as a catalyst. So you have a catalyst. This catalyst added to it, and it breaks this double bond. Okay, so it breaks this double bond, and what happens essentially is this line here. So you have two lines holding two together. Essentially, it's like two hands interlocking, and what happens is this lad will go over here, and then that means this line here, and now that line is ready to hitch onto the back of another molecule, essentially. Okay, so it's essentially ready. I'm just going to put in a new slide here, and I'll be able to draw what I want to show you. Okay, so the ethylene molecule is, so you're showing the ethylene molecule. So what you have here, guys, is I'm not even going to bother writing the letters. I'll just go sugar. You had a double bond. I'm just going to draw circles or something. Yeah, there we go. Okay, and then we added a catalyst. And then what happened to this guy is you have circle, line, circle. And this lad, remember, he went out here. Okay, and he's ready to hitch on to the back of another ethylene molecule. And then he's able to hitch on to the back of another ethylene molecule. And that keeps going on until the chain link is formed. And essentially, how a lot of you'll be thinking, okay, so well, this should go on forever. What happens is this catalyst doesn't break all these bonds. So eventually, these will all link on together until at the very end, you meet this double bond, and he brings an end to the chain. And each of these is made like that. Okay, so that is addition polymerization. So essentially, we add them together again. When you're doing these notes, guys, I've put in circles here. Can you please just try and put either you do something what I've done there, or maybe you could have something like this. You could have B A B, and then just your double bond B A B, or something along the lines of that, just to show the molecule. Okay, so I can try and keep it nice and neat. That's sort of crossways mine on this. Okay, so that's addition polymerization. Okay, so guys, I'll put up some notes just to help you with it, but just hopefully that'll continue. So we'll just go. I'm just going to get you just take a few notes on this to get this to complete this topic.